Okay, we'll get started. In this section we're going to be looking at 2H. So 2H is horizontal or kinematics problem solving, and then we're also going to be looking at 2I, which is horizontal kinematics. So the first thing to realize is that when we solve kinematics, and we'll get into exactly what that is in a second, but when we solve kinematic problems, or really almost any physics problem, it's always important to follow these first couple steps. It's never it's never a bad idea to start with these few things first. So those steps would be to write out your knowns, to write out your unknowns, and to write out your relevant equations. So first thing, your knowns. So your knowns are what you can get just by reading the problem. So just reading the problem, what information is really given to you without you having to solve anything. So those are your knowns. Your unknowns, unknowns, and again it might be technically one unknown, it might be multiple. That's what you're trying to solve for. And then the last part, relevant equations. Equations are any equations you're going to need to solve for the unknown. And again, it's important to note you might not always use equations. Typically you're going to. So every once in a while you might not need to. Typically you're going to need an equation of some kind. So let's go on to the next page where we actually get into what is kinematics. So here we go. So horizontal kinematics, that's looking at motion using equations instead of graphs. So we've been looking in previous sections at looking at motion as an xt graph, as a vt graph, right? Plotting motion visually. But there's another way to look at motion. We can look at it with math. We can look at it with equations instead. So if we look at motion mathematically, and we're not concerned with too much with the underlying causes of something, that's called kinematics. So examining motion without those underlying causes is called kinematics. And we're just going to be, it's horizontal kinematics because we're just going to be looking at motion of things moving horizontally first. So one of the big things to keep in mind here is what we're looking at when we talk about motion. So these are all the quantities that we're going to be looking at when we examine motion. And a lot of times you're going to have problems where you're going to have to solve for a specific one or more of these basically. So the first one you might see is displacement, so the change in position. Velocity, and this is going to have the symbol v. And again, if you see just v, velocity, you assume that's constant. So how fast that thing's moving and in what direction. This one's a little bit new, but not too bad. So initial velocity, that's how fast something's moving at some initial point in time, so before something happens to it. So remember, it's v subscript I. The next one is final velocity. So that's the velocity after something happened to it. So after some type of action happened to it. So again, v subscript f, f for final. The next one's acceleration, a. So that is the change in velocity, how velocity is changing, whether that be speeding up or slowing down. And the last one is time, t. And that's how long something takes to happen. You might also see delta t sometimes. Delta t, t, for our purposes, are going to be the same thing. They're both time. So these quantities up above are going to be related to each other by the following equations. And I'm just going to go through them. They're going to make more sense once you actually see how they're used. So the first one is the velocity is equal to the displacement times or over the time. So that's an equation that works if you have constant velocity. So if you have constant velocity, that equation is valid. Then there's the next three. So displacement, delta x, is equal to the initial velocity times time plus 1/2 the acceleration a times the time squared. The next one, the final velocity squared, is equal to the initial velocity squared plus 2 times a times the displacement, or the change in position. And then we get the last one here. The final velocity is equal to the initial velocity plus the acceleration times the time. So it's important to note that these last three equations can only be used if the acceleration remains constant. So again, only valid if that acceleration does remain a constant number. So what that means is, like, the acceleration has to be 5 meters a second squared, or it has to be like -10 meters a second squared. It can't keep jumping around. Otherwise, you're going to have to use multiple equations. So to use any one of these, the acceleration has to remain a constant value. It has to have the same number, it has to be pointing in the same direction. So that's something to keep in mind. So that's all of the notes. So that's just some stuff to keep in mind when you're solving kinematics problems or just physics in general, and what kinematics means, so what we're examining, and then also the equations that we're going to use to solve for any one quantity. So now in the last part we're going to look at a problem with this. So let's see, here we go. So please make sure you solve it out first before you see the solution. So again, make sure you're solving it out first. Okay, I'll get started. So I'm going to read it off first. We have a Dodge Charger starts speeding up from rest. From rest. It accelerates at 3 meters a second squared for 10 seconds. What is the velocity at the end of 10 seconds? Okay, so let's maybe draw this out first. You don't need to, but it's not a bad idea. So it's at rest, and then it's accelerating, and then it has a new velocity. That's what's happening, and it's asking, what is this velocity over here, basically? So this problem, again, we're going to follow that strategy that we saw at the very beginning. So the first thing would be, what are our knowns? What do we know? Well, we know it's accelerating from rest. It's speeding up from rest. So it starts at rest. So that means initially its velocity is 0 because it's standing still. 0 meters a second. That's initially what its velocity is. It's at rest. Then what else do we know? We know it accelerates at 3 meters per second squared. So we know the acceleration is 3 meters per second squared. And we know that acceleration is happening for 10 seconds. So we know that acceleration is happening for 10 seconds. T is equal to 10 seconds. And it's saying, okay, what's the velocity at the end of these 10 seconds? So after 10 seconds of that acceleration, what's the new velocity? So that's actually our unknown. So these are our knowns up here, right here. Now we have our unknown, so we know the final velocity is what we're looking for. So that's the knowns. This is the unknown right here. Now we need a relevant equation. So we need an equation that basically uses these things right here, uses things that are known, and then also includes one thing we don't know. So we need an equation that has initial velocity, acceleration, and time in it. Or maybe not all of them, but at least some of those, and then lets us solve for final velocity. So it has to be one of those. So again, includes these knowns, and then it also includes the unknown. So if you flip back to the equations, you're going to look at them, and you're going to see there's really only one equation that fits this bill, and it's this. Vf is equal to Vi plus At. So if you think about it, before you plug in any numbers, the initial velocity is known, the acceleration is known, time is known, and the way it's written, we can solve for Vf pretty easily. So we know what the initial velocity is, the acceleration, the time, and it has VF, what we'd like to find in it. So we're just going to plug in at this point. So before you do any math at all, most of it is really just figuring out what information do you have, what are you trying to figure out, and then what's your equation. And then the very last part is just a little bit of algebra. So VF is equal to 0 plus A, 3, times time, 10. Again, you don't need to leave the units in when you're plugging in. Just make sure you keep them in the end, or you add them to the final answer. So if we do this, it's going to be 30, and it's 30. The units are going to be the standard units for final velocity, because if you plug all standard metric units in, you'll get standard metric units out. So you plugged all standard metric units in, you get 30, and for velocity, the standard unit would be meters per second. So that's the idea. Really, it's the same thing. It's what are your knowns, what are your unknowns, unknown in this case, what is your equation, and then just a little bit of algebra solving for it. So again, I think the important thing is being able to pull out information and being able to select an equation that makes sense for what you know and don't know. So that's about it for now. Make sure you have the notes, make sure you have the solution copied down, and that's it.